All right, students, I'm going to explain the last set of notes for those that were absent. Uh, this is the general idea of what we're going to be applying to the problems right here. Just remember from SOHCAHTOA, which each of these stand for. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So the worksheet from last week, we only worked with sine, cosine, and tangent. The first one, the second worksheet that you had last week dealt with on one side the reciprocals of these, so cosecant, secant, and cotangent spelled down here, and then a new set of problems that we'll look at as well that deals with stellar quadrant angles, triangles within those. So one thing to remember is, as I was explaining this section of problems, some people thought that they were going to be completely different from these up here. Whenever we draw a 30-69-degree triangle, these are always our side lengths. It doesn't matter if it's sine or cosecant, cosine, secant, or tangent or cotangent. It doesn't matter. You're looking at the degree. If it's 30 degrees, it's always going to be these three. If it's 60 degrees, it's always going to be these three. If it's 120 degrees, it's always going to be these three. It doesn't matter what the trig function is. So that's why the second sheet, the first half of it, on one side was actually similar to the prior assignment. It just happened to be the reciprocal trig functions that you're finding. Okay. Just as this, all 45, 45, 90s within the unit circle. Again, these are only within the unit circle because unit means one, so the hypotenuse is 1, or the radius of the circle is 1. So that's why these are already always set. These numbers cannot change in these types of triangles since the hypotenuse is always 1. Okay. The other thing to remember is that if the degree lands, and so in all of these cases, if it's one of these, obviously we're drawing triangles within whichever quadrant, 1, 2, 3, or 4. Now, if it's not on or within the quadrant itself, it's on either the x or y axis, we're not going to have these numbers. We're going to either have 1, 0 if it lands on 0, 360 degrees, or negative 1, 0 if it lands on 180. Or if it lands on the y-axis, we either have 0, 1 for 90 degrees or 0, negative 1 for 270 degrees. So we would just be drawing a segment for these angles right here if they asked us to find anything with these angles right here. Otherwise, it's going to be a multiple of the 30, 60, 90, or a multiple of the 45, 40, 90s, and these will all be triangles that you'll be drawing within quadrant 1, 2, 3, or 4. All right, so let's look at examples. So we have the tangent of 210. So again, the very first thing we draw is our quadrants. Draw your x and y axis. Okay, 210 degrees, obviously between 180 degrees and 270 degrees. So it's in quadrant 3. So we draw a quadrant 3 triangle. How do we get this reference angle theta? We do 210 degrees minus the 180. That gives me 30 degrees. Remember, we're always going to be subtracting or adding, subtracting from one of the angles or one of the numbers on the x-axis, either 180 if we're dealing with quadrants 2 and 3, or 0 in quadrant 1, or 360 in quadrant 4. 0 and 360 being right here. Okay, so 210 minus 180 is 30 degrees, so that makes the other one 60. So we have our 30, 69 degree triangle. Again, the hypotenuse is always 1. Opposite the 30 degree side is always 1/2. Opposite the 60 degree side is always square root of 3 over 2. The only thing that's going to change is their signs. What I recommend is that you put a point here and put the signs of any point that would be in quadrant 3, negative and negative. That way you make sure that your x is negative and your y is negative. That's the only way to add to the numbers here. Remember, the hypotenuse will always be 1. That is never going to have a sign change. So tangent now. So that's just drawing our triangle. It doesn't matter if it's tangent, sine, cosine, cosecant, cotangent, etc. Okay, that triangle is always going to be the same because it's 210 degrees. Now we got to just do whatever this trig function tells us to do. It says tangent. We know tangent is y over x, okay, or sine over cosine. So now I just fill in the numbers. Y, negative 1/2 divided by x, negative square root of 3 over 2. We know that division is changed in multiplication by the reciprocal. and then we have a negative times a negative, so that's going to be a positive there. The 2's cross cancel, and so we're left, when we multiply across, 1 over square root of 3. We now need to remember that we cannot leave square root of 3 any square roots in the denominator, so we need to rationalize the denominator, change it from irrational number to a rational number, one that can be written as a fraction. So we multiply by that same number, top and bottom, numerator and denominator, because now we're just multiplying by 1, so we're not changing the problem at all. Multiply across and you get square root of 3 over 3. And there's our rational number now in the denominator. And there's your answer. It's not simplified from there. Okay, so up here would be square root of 3 over 3. All right, next one, sine of 330. So again, we just draw a triangle in the quadrant that's in 30 degrees, which is between 270 and 360, so quadrant 4. Okay, draw yourself, well, first draw your XY axis. Now draw your triangle in quadrant 4, your right triangle. Go ahead and put your signs. Any point in quadrant 4 is going to be positive for the X and negative for the Y. So that way we make sure we check our signs when we're done here. Again, it's at 30, 60, 90. So notice the numbers are exact same as we had over here because it's at 30, 60, 90. We have 1 opposite 30 degrees, 1/2, and opposite of 60 degrees, square root of 3 over 2. Just like we have over here, no different at all. So now we just got to check our signs. X better be positive, yes it is, and Y better be negative, yes it is. So now we just do whatever the trig function says. It only wants a sign. We know the sign is the Y coordinate. So what is the Y coordinate here? Negative 1/2. There's our answer. So that is a review of the first sheet we had done. Okay, so now let's look at this last sheet that I gave out to you. And now it's just dealing with the reciprocals of sine, cosine, and tangent. Again, we draw the triangles exactly the same. That does not change. So cotangent of 30 degrees. Draw our quadrants. 30 degrees in quadrant 1. Again, the reference angle comes from 30 minus 0, so 30 degrees. So we have 30, 60, 90. So it's the exact same as we just had in the last two we did. Hypotenuse 1, opposite 30 degrees side is 1/2, opposite 60 degrees is square root of 3 over 2. That does not change. We check our signs for quadrant 1. Both of them are positive. Both of them are positive. We're good to go. So again, that triangle for 30 degrees is always drawn the same way. It doesn't matter if it's sine, cosine, tangent, cotangent, cosecant, or secant. Okay, now we just happen to do whatever this trig function asks us to do. This trig function is cotangent, which is adjacent over opposite, and all the adjacents are the x, and all the opposites are the y in this reference angle. So x over y, x coordinate, square root of 3 over 2, divided by the y, 1/2. We know division is multiplication by the reciprocal. So multiply by 2 over 1, cross cancel our 2's, multiply straight across, and we're left with square root of 3. There's our answer. Secant of 240, again, 240 is in quadrant 3, between 180 and 270. So now, draw our XY coordinate plane, draw our triangle in quadrant 3, our right triangle in quadrant 3. Remember, we get our reference angle from doing 240 minus the number on the x-axis right here, 180 degrees. So it gives me this 60 degrees right here. So that puts this one at 30. We have a 30, 60, 90 again. The numbers don't change. 1, 1/2 opposite the 30 degree side, and square root of 3 over 2 opposite the 60 degree side. The only thing we have to now check is our signs. Since we're in quadrant 3, if we plot any point in quadrant 3, such as right here, it's going to be a negative and a negative. So I go up here and put on negatives on both the x and the y. Now our triangle is complete with what our numbers are. And now we just do this trig function. Secant. Secant is hypotenuse over adjacent. Okay, the reciprocal of cosine. And remember, the hypotenuse is always 1. So 1 divided by the adjacent, negative 1/2. And division is multiplication by the reciprocal. Multiply straight across and you get negative 2. It's already simplified. So the answer is negative 2. Up there. Okay. Here would have been square root 3. As we already had. Okay. All right. So that's the one side of the new worksheet, this last one you're just given. And let's go to the other side of the worksheet now. This is a little bit newer. It's still dealing with our quadrant triangles, as you see right here. The only difference now is the hypotenuse is not going to be 1, so we're not dealing with a unit circle any longer. But they go ahead and give us all the information we need, and we will go ahead and fill in the third side by using either the Pythagorean theorem, a squared plus b squared equals c squared, or if you have your Pythagorean triples memorized, as I've quizzed you all year long, starting in Q1 on extra credit on quizzes and tests to memorize. There's a handful of you have those memorized. Those that have memorized it, this assignment can be done in 10 minutes. Okay, the 10 problems on here. All right. It says, if theta is an acute angle of a right triangle, acute means between 0 and 90 degrees. So that tells me it's in quadrant 1. So again, I draw my quadrants, x and y axis, draw a triangle in quadrant 1, put my theta right here. That's my reference angle every time. And it says the cosine of that reference angle is 24 over 25. We know cosine is adjacent over hypotenuse. So the adjacent side right here, hypotenuse right here, 24 over 25. Like I said, if those have Pythagorean triples memorized, you know this needs to be 7 right here, 7, 24, 25 Pythagorean triple. If you don't know that, you don't have it memorized, then you have to work out a squared plus b squared equals c squared, and then you solve your b squared there, and you'll get a 7. Okay, now the only thing we need to check is if I plot a point in quadrant 1, are my signs for both x and y positive? Yes, they are. That's the only thing I would be changing here. So you notice it's almost, we're going through the same steps almost as we did in the last 2 worksheets. The only difference is this time they give us a different hypotenuse number-wise. Okay, so there's our triangle all set up. And now we go ahead and answer the trig question over here. What is the cotangent of theta? Our reference angle cotangent we know is x over y, which is the same thing as adjacent over opposite. So x over y, 24 over 7, that does not simplify, so you're done. That's simple. If it's simplified, we'd have to simplify it. All right, next one. If the theta is in quadrant 4, so it's tell me what where to draw my right triangle. So I draw my x and y axis, draw a triangle in quadrant 4. I could go ahead and put in my signs down here. As a reminder, like I said, this is just a good habit for you beginners. As after you do it again next year in Algebra 2, you should have it mastered, and by the time you hit it with pre-calc and calculus, you should be able to draw the triangles themselves. But people who were not drawing on their assignment weren't drawing the x and y axis. Several people who just tried drawing the triangle itself were always drawing quadrant 1 triangles for no matter what degree it was. We were talking about the degrees before. Okay, and they were drawing them wrong, putting wrong numbers on wrong sides, didn't have the right sign numbers because they were always in quadrant 1, or they tried to guess what it'd be in quadrant 3 based off of quadrant 1 triangle. Always draw your x and y axis first, so you make sure you draw your triangle correctly for that quadrant. All right, so we drew our quadrant 4 triangle. This is the sine of theta. Theta is always the reference angle. So it'll always be right here between the terminal side and the x-axis. It's never going to be over here between the terminal side and the y-axis. Always between the terminal side and the x-axis, no matter what quadrant it's in. Okay, so here in quadrant 1, right down here in quadrant 2, or right here in quadrant 3. Okay, so they tell me the sine is negative 15 over 17. So sine is opposite over hypotenuse. So I have my negative 15 over 17. Now, one thing to remember, as I've written right here, the hypotenuse always has to be positive. Okay, our x or y can be negative or positive depending on what quadrant it's in, like down here, but the hypotenuse will always be positive. So say, for example, they put 15 over negative 17. I would need to move that negative up and put it in the numerator because the hypotenuse must always be positive. All right, so we have the negative 15 and 17, Pythagorean triple, 8, 15, 17. If you have that memorized, boom, you can just quickly fill it in, and you got your positive for the x and negative for the y. You're all good to go. Okay, if not, again, you have to use Pythagorean theorem, a squared plus b squared equals c squared, solve for the missing side, get your 8. Now we go ahead and just answer the trig function itself, and what's the cotangent of theta? Cotangent is adjacent over opposite, or x over y. X 8 over y negative 15. Okay, 8 over negative 15. You see that answer here. You notice I put this here as well. Most answer keys will never usually put a negative in the denominator, and they'll move it up and put it in the numerator. These are the same answer. Just because this negative is in the numerator does not mean this 8 should be negative, just because the negative sign is with it. 8 positive divided by a negative is a negative. A negative divided by a positive is a negative. These are the same thing, but don't think that this sign correlates with this side right here, meaning that I messed up and somehow it should be negative. It's not. Okay, positive in the x direction, negative in the y direction. You're in quadrant 4. Okay, one final example of doing this right here, and then we're done. All right, so it says if theta is in quadrant 3. So again, we draw our x and y axis. Okay, draw a triangle, right triangle in quadrant 3. Theta is always right here between the terminal side and the x-axis, or you can say the hypotenuse and the x-axis. Okay, and it says that cosine is, let me erase this, what originally was here. Okay, cosine is negative 24 over 25. Cosine is adjacent over hypotenuse, negative 24, adjacent over hypotenuse, 25. And again, you should know your Pythagorean triples, 7, 24, 25. That does not change. And again, if you don't, you'd have to use Pythagorean theorem to get your 7 right here. Okay. Again, go ahead and identify what your sign should be. If it's in quadrant 3, obviously we're going negative x and negative y. So both your signs on your x and the y should be negative as they are right here. Okay, so don't forget, if you did Pythagorean theorem, you get 7. You put the 7 here, but then you have to add on the negative sign since it's a negative in the third quadrant for any y coordinate. It's a negative for the x coordinate as well in quadrant 3. Okay, so now we have our triangle filled in, and now we just go ahead and answer the trig question. It says, what's the cosecant of theta? Cosecant is the reciprocal of sine, which then, remember, sine is opposite over hypotenuse, so the reciprocal of that is hypotenuse over opposite. And remember, the opposite is always the y coordinate, so if you want to think hypotenuse over y coordinate. Okay, either one. If you want to just think hypotenuse over opposite, hypotenuse over the opposite, remember the opposite is in reference to the theta here. That's the opposite side, which then obviously is the y coordinate, which all you have is hypotenuse over y right here. Okay, so hypotenuse 25 over the opposite, negative 7, and you're done. It does not simplify. Again, if you want to go ahead and put that in the numerator, then you'd have the negative in the numerator, you'd have negative 25 over 7. Okay, same answer. So you're not going to get marked wrong either way. Okay, just know most answer keys will just write it as negative 25/7 for the negative in the numerator. Okay, so just know that. Again, that negative does not mean so 25. We know the hypotenuse always has to be positive. Okay, that should help solve any of your problems on this last worksheet. And remember, it's these two, this worksheet right here that I just gave you and the prior one, that your test will be over this coming Thursday or Friday, depending on which day you have class. Tuesday and Wednesday in class, all we're doing is reviewing your worksheet, this last worksheet, and doing more practice problems with it. But you've got this video right here that explains everything you need to know for this test. We've gone through these type of questions, these three right here. You've got your reciprocal properties, secant here, cosecant, and cotangent are your reciprocal ones. And we practiced again sine, cosine, and tangent in this first one right here. Okay, that's the only types of questions that are going to be on your test this coming Thursday or Friday. You probably have somewhere between 15 and 20. I might do 5 of these types, sine, cosine, tangent, 5 of the reciprocal ones, 5 of these ones, the reciprocal ones, and 5 of these type right here for total 15, or somewhere between 15 and 20. Okay, and we'll just practice that Tuesday and Wednesday in class. All right, that ends this video.